Okay, so talking about today's question, let's just move on to that question, right? So let me just see, am I visible or not? Yeah, it is visible, right? Okay, let's start by just reading the problem. Today's question is count the number of arrays with k matching adjacent elements. Okay, you're given three integers and n, m, k. A good array of size n is defined as follows. Each element in array is the inclusive range 1, comma m. Exactly k indices I, where I is smaller than equal to 1 is smaller than equal to I, and I is in the range of 1 to n, where n is exclusive, satisfies the condition. Okay, return the number of good arrays that can be formed since the answer may be very large. Okay. So, like, I think I understood the question. It's a basic question, but let's see. Okay, let's just understand the problem in more detail. N is equal to 3, m is equal to 2, k is equal to 1. Okay, so the length should be 3. I can use the numbers from 1 to m, and there should be exactly k number of pairs, right? So here it is one pair, here it is one pair, here it is one pair, and here it is one pair. So total four pairs we have. Okay, let's take another example where k is equal to 2 and we have to choose the numbers from 1 to 2. Okay, so 1, 2, 2 pairs, 1, 2, 2 pairs, 1, 2. Okay, understood. Input n is equal to 5, k is equal to 0, then nothing is going to be, there's no pairs, right? Only two pairs are there. Okay. Let's just talk about the edge cases. What if the mm, m, what if m is greater than n, let's suppose, because there may be a possibility that m is greater than n. Here it is written m is smaller than n. No, here it is not written, right? So maybe m is greater than n, then what? And if you want to make a pair, so it is going to be still the same, right? Okay, it is not going to make any difference. Okay, so one brute force approach, which is not going to work, obviously, is, let me just show. I haven't solved this problem till now. Yeah, one brute force approach, which I think of as making all different possibilities, which is I think like n minus 1 pairs for n, like size array. There is going to be n minus 1 pairs. Okay, so we will make every different possibilities, and we'll just check that how many pairs or how many like pairs like this means the adjacent pairs are present or not. If they are present, we'll just add it into our answer and we will return the final answer. Let's just think, and let me just show you how I'll do this. Let's suppose I have an array which is like let's n is equal to 3, m is equal to 2, and k is equal to 1. Let's suppose this example I'm taking. Okay, so what I'll do is, what are the possibilities that I have? One is I can have, I'll just keep the uh, okay, one possibility is keeping all ones. Yeah, one possibility is this. Another possibility is keeping one, one, two. Another possibility is 1, 2, 2. Another possibility is 1, 2, 1, right? So there is going to be numerous like there can be many possibilities in which we can just have some array where adjacent pairs are equal. If it is greater than this, so this is not going to be our answer, right? So like let's write a code in which we are making every single pairs, and we'll just check for the adjacent pair. Is it equal or not? If it is equal, so we'll just add it into our answer. If it is smaller or greater than the k value, like in this example you can see here, the number of pairs is 1, 2. So here it is 2 pair we are having. So this is not going to be our answer. So if the pair exceeds the number of given k, so we'll not add it into our answer, or else we'll just add it into our answer, right? So let's just think of and also the answer can exceed, so we'll just keep a modulo operator here, modulo variable here. Mod is equal to 1 e9 plus 7, right? Okay, let's just create a variable int answer here itself. Answer is equal to 0, okay? And we'll just keep a void. In this, let's name it generating all pairs. And in this, I'll just give it few variables. Let's just think. Start by start. Okay. What are things that I have to give to this generate all pairs? What does it need? First of all, in which index it is standing. So let's just write here in which index it is starting, from which index. Another one is nmk, it is basic things, so these things. And also I have to keep track of a vector, right? So I can make a global array of vector which is going to be global, and we'll just keep the uh, keep all the elements in this global vector, right? So yeah, mm, let's start by coding this out. Let's think. If I'll just keep a global vector, and I'll just keep generating the pairs, will it work or not? I think this is going to work. Okay, what are things that we will get here and we need here? Int index, comma int n, comma int m, comma int k. Okay, so if index, let's write this base case later on. First of all, let's think of computing or generating all the pairs. Okay, so for int I is equal to or idx equal, start from the first index, and starting from the very first index, what I'll do is I'll just make pairs, right? From the very first index to the very last index. Okay, I also need the value which is going to be same, right? mm, idx is equal to value for and idx is equal to and idx is equal to 1 to rdx smaller than n ठीक है right if I'll just generate all the pair this will not give me the correct answer the time complexity will be very large right one second okay let's just start by iterating through all the elements for int I is equal to or index is equal to 1 to I is smaller than equal to n I plus plus okay okay what I'll do is I'll just keep a vector here in which I'll keep the pairs vector pairs I'll just resize it later on like pairs dot resize to n okay and after this what I'll do I'll just keep adding all the elements to the value given yeah so I'll just keep the pairs of index pairs of index is nothing but the value given which is equal to it is going to run from 1 to m because we are going to have 1 to m items as you can see here like n is equal to 3 So they are m is equal to 2. So we are going to have try for all the possibilities. So it is going to start from 1 and go to till m. So yeah, we'll just keep the value here. Yeah, and then we'll just again call this function, and we'll just increase the index by 1 comma m comma k. So this will generate all the possible pairs, and yeah, the base case, if uh, index is equal to n, we'll just add the we'll just again check for all the possibilities that we have, right? So for int idx is equal to 1 to idx is smaller than n, idx plus plus, what I'll do, I'll just keep checking if uh, pairs of idx minus 1 equal to pairs of idx. If it is equal to this element, I'll just add the ans, or I'll just keep a variable here, int temporary count is equal to 0, and I'll just count plus plus. Okay, yeah. And again, if the value of temporary count is equal to k, because as you can see in this example, it is exceeding the value of k. So if it is equal to k, it is going to start from 1. I'll just increase answer by 1, or I can do something as answer is equal to answer plus 1 mod mod, because like it is going to be a very large value, right? I made all the pairs. I'll resize. Okay. Now I'll just call this function. What is the name of this function? Generate all pairs. In this, the first index is 0, the value of n, m, and k. Let me just try run this code and check everything is working fine. Let's start from the very first index. So let's take for this example only n is equal to 3, m is equal to 2, and k is equal to 1. So if I'll check for this example, n is equal to 3, right? So at the very first index 0, what I'll get is pairs of 0 is equal to 1. Okay, because see, we are starting from 1 to n, right? So here also we are starting from 1 to n. So pairs of 0 is equal to idx 1. Okay, again it will go to that, go to the same, it will call the same function. And again in this function call, the like when the index is equal to n, the first array will look like this, 1 comma 1 comma 1. Yeah, this array will look somehow like this. And here in the temporary count, when it will count the number of pairs, the value of temp count is equal to be uh, value of temp count will be equal to 2, which is greater than k. So the answer will not be modified, and it will just return. I'll just have to write return now. Okay, it will just return the function, and after that, for idx is equal to 1, idx is smaller than, okay, this return, it will again check for the second possibility, which is the second array, which is going to be uh, 1 1 2, and after this the value of temp count for this uh, array would be 1, which is equal to k. So it will just add this into our answer, and I think this solution will work fine. Okay, let me just see, am I like visible or not? Yeah, I'm visible. Okay, let's just run this code. Is this working or not? Okay, it is working. Let's submit this code. Okay, yeah. As you can see, the time complexity is exceeded because let's compute the time complexity. What is the time complexity of this solution? Here, what we are doing is time and space complexity. Let's just compute this. Time complexity will be equal to uh, the space complexity will be equal to the like the time means the recursive calls and making all the pairs. So it is going to be big of n cross m. Yeah, so big of n cross m. Okay, and the time complexity will be also equal to big of n cross m. Why the solution is not working? Because let's just see the constraints. Yeah, so it is 10 to the power 5, 10 to the power 5, which is going to be close to 10 to the power 10, right? And we all know, it is not the optimal solution, not 10 to the power 10, 5, 5, 25, right? Okay, let's just think of another solution. mm, well, I'm checking for all the pairs. Can we use dp here? Mm, Making dp also will take the same space complexity. It will just not work. Okay, let's think of another solution. Okay, what we are doing here is we are making pairs, right? What is the value of n is equal to 3 and m is equal, we should use the values from the range 1 to m. Okay, and there are k pairs which should be equal, right? So for n is equal to 3, m is equal to 2, and k is equal to 1. Okay, we have to make pairs, so we can use something like combinatrix. Okay, in which what is the value of total pairs, which is going to be n minus 1, that is nothing but 2. Okay, so if we have the array like, let's compute here only, we have the array like 1 comma 1 comma 2. Okay, so or we have the array like 1 comma 1 comma 2 comma 2. So in this example, what we are seeing is here we are having uh, one pair and one non-pair, right? Here also we are having one pair and one non-pair, right? Let's take a big example and understand it in more detail. Let's take this example, right? Okay, in this example also we are having two adjacent pair and one non-pair. Here we are also having two adjacent pairs and one non-pair, right? Yeah. Mm, okay, so the idea is simple. We just have to check that for how many possibilities we can have this this diversion, or you can say this partition, so that there will be no equal pairs, and how many ways we can just put it. Like you can see for this also, for this example also, what we can do is we can just keep a array. Here also we are having one pair and two non-pairs, right? Okay. Okay. Okay, before uh, so we need few things before writing the solution, which is going to be the value of NCR, value of in how to calculate the value of inverse factorial, uh, value of factorial, because we are going to compute the value of NCR. Also, we'll just find how many runs it will take to solve this problem. And the last one, uh, number of ways we will arrange all the possibilities. So, yeah, I think this is going to work. But the main thing is how this idea is going to work. That's the main thing, right? So, we can find two things: the number of arrangements that we will keep in mind, and the second one is number of uh, the first one number of arrangements, and the second thing that we'll keep in mind is number of partitions from where we will check for the unequal pairs, right? So this is our idea. Let's just understand this idea in more detail. The total number of pairs is equal to n, right? So the is equal to n minus 1, okay? And we have been given that the total of unequal pairs or equal pairs is equal to be k, right? So what is the number of total of unequal pairs, which is going to be n minus k minus 1, right? So with this, we can also find uh, the total number of partitions that we have to keep in mind to keep computing the equal pairs. So the first thing is we have to calculate NCR, in which n is equal to be in this total ways we can update the solution is n minus 1 cr minus 1, right? Total number of pairs is n minus 1. Total number of runs is n minus 1, r minus 1. Okay. And this run is nothing but uh, n minus 1 minus 1 minus of k minus 1, right? Okay. So n minus k minus 1. So we can conclude to a solution that the expression which was n minus 1 c r or r minus 1, it is going to be n minus 1 c k. Okay, uh, this is the solution that we need for choosing choosing equal pairs, equal adjacent pairs. Okay, yeah. So this was our idea to compute this. And the second thing, the arrangements, right? For arrangements, for the first one, like for let's take this example. For this one, what are the possibilities that we have? Yeah, for this example, what are the possibilities that we have? We have somewhat like 1 1 2 and 1 2 2. Okay, so in this solution we can see that 1 1 2 and 1 2 2, right? So this element have m possibilities to be kept. Yeah, like 1 2. Also this one can also have m possibilities. So how much possibilities the second element have? It is going to be uh, m minus r. Let's understand this. Suppose I have this element as 1 and 2. I have the value of m is 2, and that's why the range of m should be 1 and 2 only. So one can have different possibilities ranging from 1 to m, right? So it is going to be m into m minus r. Okay, yeah. To compute all this idea, we need few things, which is going to be the inverse pairs. We'll need inverse pair. Okay, the first one will have m choices and the second one will have m minus 1 choices, right? Okay, okay, let's just write this code. uh, let's initialize some vector and factorial array, comma, uh, inverse factorial factorial array. Okay, second one we want as int power generator or power uh, computation. Power, let's keep it power. Okay, so we'll have two variable as two parameters, int base comma int uh, let's name it power computation. The base and the power. So what I'll do is I'll keep a long result is equal to 1, and I'll keep adding the or keep computing the power, while power, if power and 1 is valid, just keep adding the power in the result. Okay, result is equal to result into base mod okay. Now I'll just uh, base into base mod right. Okay, and I'll again power. Okay, so this will give me the value of the result. Okay, return result. And also apart from this, I'll just need a uh, computing inverse factorial and the value of the factorial array. So what I'll do is computing inverse factorial or okay, let's just think of computing inverse factorial. Okay, I have a function, right? Computing inverse factorial. How I can compute the value of the inverse factorial? I need a value and let's just keep it as a pass by a reference. And what is the name of the array? Inverse factorial array. Inverse factorial array is equal to vector end of n. Is equal to okay, before this I'll make another and modified inverse and value return the uh, exponential part, which is power computation. I need a base and I need a mod minus 2, right? I'll keep a variable here mod is equal to 1 in 9 plus 7. Okay. Okay, Java inverse factorial is nothing but computing the modified inverse uh, of the factorial part, right? So let's just leave it and move to our next part. I want to compute the inverse factorial, right? I minus minus inverse factorial of I minus 1 is nothing but 1 LL inverse factorial of Computing the inverse factorial. Initializing the long. It will work fine, I guess. Okay. Void. I'll just keep it void. Computing factorial and value. Again, for this also, I'll do the same thing. Computing factorial is nothing but I'll keep a variable n which is going to be global. So computing the factorial part is not easy. Factorial array of 0 is equal to 1 and keep updating smaller than ni plus plus I is equal to 1 long into I into factorial of I minus 1. Okay, this will just, it is simple, and we are just pre-computing the results. So void pre-computation and value, compute the factorial, compute the inverse factorial, okay. Yeah, so this will give me the inverse factorial and also the factorial that I was thinking of. Okay, yeah, pre-computed, I have computed the factorial array. I have also uh, updated the inverse factorial array. I have thought of power. I have also computed the power. Okay, now the part left is computing the NCR. So int NCR. So int n comma int r. If r is smaller than 0 or r is greater than or not equal to greater than n, return 0, or else just return uh, L into int fact is equal to uh, inverse fact 1 is equal to computing the inverse fact inverse array of n minus r and int inverse fact 2 is nothing but r. Okay, and int fact is equal to factorial of factorial of n minus simple n. Okay, okay. Let's just return this. Return like NCR, so it is going to be 1 LL into the fact 1. Okay, I'll just keep track of all these. Hmm. Long. First of all, I'll just keep factorial into inverse factorial into inverse factorial 1 and whole mod, right? Okay. N minus r into n minus r. Okay, this will just try run this part. 4 6 4 minus 2 mod. Just remove the mod part for now. Pre-compute the first part. Pre-computation of n. ठीक है, now choosing for the pairs that I have to do. So n ways to choose 12 parts will be equal to nothing but NCR of n minus 1 comma k, right? And choosing the uh, ways to arrange will be equal to NCR of the same, or we have decided m into where is the value, yeah, m into n minus 1, right? So it is going to be long. So ways to arrange is 1 LL into m into I have to find the power, right? So power computation of m minus 1 comma n minus 1 minus k, which is the value of the run, and this is going to be mod. Okay, and I'll return the like calculation of both the arrays. So it is going to be 1 LL and ways to choose equal parts into ways to arrange. Okay, this mod. Okay, before going any further, let's just see if my solution is working or not. talking about the base condition. If power and 1 result is equal to result into base not where I'm updating the value of base, right? I just keep the value of not be equal to inverse factorial of I into I, right? Inverse factorial of I minus 1 will be equal to 1 long into inverse factorial of I into I mod into value. If I'll just write int n here, int n here, computing the values. Just have to define. Let's submit this code and see if it is working or not. There may be some compilation errors, I guess. Yeah, computing inverse factorial. Okay, in this part, right? This part I'll need two values. Modified inverse factorial. The first one I'll just give it as n comma just give factorial of n. Okay. Okay. Time limit exceed. There's some place. Let's just try it in this code. First of all, I'm pre-computing the value of n, right? So just pre-computing, computing the factorial till n. Okay, uh, computing factorial till n, computing just starting from 0 is equal to 1, 1 into factorial of I minus 1 and mod word of computing inverse factorial, initializing the inverse factorial of n plus 1, inverse factorial of n is equal to modified inverse factorial is greater than 0 I minus minus inverse factorial of I minus 1 is equal to I 1 long okay. uh, Till here it is fine. After that, ways to choose equal paths n minus 1 comma k. Okay, n minus r, and here I am passing n minus 1 comma k. So checking the pairs, yeah, n minus 1 comma k is all right. n minus 1 minus k mod. Uh, Power computation int 1 while power I'm updating the power. Okay, it is also fine. It's greater than 0 mass minus I smaller than 1 I plus plus. Mm, Formatting delay PL. For the TLE. Mm, Computing the factorial till n time should be equal to n runtime error. Okay, it is giving me runtime error, right? So, line 58. Okay, base is equal to base mod k, right? I'm just updating the base, right? Can I use long base? Again, TLE. Where is error? Okay. Before we move further, let's run this code. Yeah. So if I just submit this code, yeah, accepted. I just have to do constant add the value here. Also, I have to update by long because yeah, the limit was exceeding. That's all.